Good morning, everyone. Myself, Satya. I will be facilitating this training. I cordially invite you all to this AWS Associate level training. So to receive the regular updates about this training, please do subscribe to this channel and enable the notification button if you have missed it. So we are on day 8. So today's class will cover a variety of important topics. So the agenda for today's class is displayed on your screen. So the first topic for today is storage devices and their performances. Let's take a look at the various hard disk drives that are used in our computers, servers, laptops, etc. So the first image shows SATA hard drive. SATA stands for Serial Advanced Technology Attachment. So it is a type of a rewritable mass storage hard disk device. Also, the default storage type used in our traditional desktop computers, laptops, as well as servers. So SATA hard disk costs less and are typically 75% less affordable than the latest technology of SSD hard disks. So these hard disks will have mechanical moving parts such as a spindle motor, read-write arm, etc. So a larger disk in this image, what you see, which is a 3.5-inch hard disk that is commonly used in our desktop computers as well as servers. And the smaller one onto the right side, which is a 2.5-inch hard disk, which is used in laptop computers. So here you can see this is what used in laptops, whereas this one is used in desktop computers. So the next one is SSD hard drive. So SSD stands for solid state drive. This has non-volatile flash memory that can store persistent data and have no moving parts that are found inside the SATA hard disk. Whatever the moving parts that you see in SATA hard disk, that will be absent here because this has got the flash memory, non-volatile flash memory. So the SSD hard drives operate at a minimum of 3 to 4 times the speed of standard SATA hard disk. It is very fast as compared to the traditional SATA hard disk. So let us see what is there inside these storage devices. If you open the hard disk, the first image is SATA hard disk and the second one SSD hard drive. These are all the parts that you see. So here in the SSD, in the SATA hard drive, you can see a plotter. Okay, so this is the plotter. So this has got, this is the storage media where the files, the operating system, your picture files, all of them are stored in this place. So the next one is the spindle. Let me remove this. Okay, the next one is the spindle motor. This is the motor that will rotate this plotter. Okay, this plotter will be rotating at a great speed with the help of this spindle motor. Same time, this read-write head will access. Here you can see the read-write head, which is sitting on the plotter, reading the data as well as writing the data. The speed of this traditional SATA hard drive depends upon how fast your spindle motor rotates. There are two types of speed. One is 5,400 RPM, that is rotations per minute. That means this spindle motor will rotate at a speed of 5,400 rotations per minute. The next higher one is 7,200 RPM, 7,200 rotations per minute. So the faster the spindle motor rotates, the faster the hard disk works, will be able to exchange the data as well as do the read and write operation. So your computer speed not only depends upon the RAM memory, what you have, 4 GB, 8 GB RAM, whatever, apart from the CPU, the processing CPU, whether it is i3, i5, or i7 processor. It also majorly depending upon the type of hard disk drive that you're using. Same time, in case of SSD, it has got cache. It has got a cache memory wherein the frequently accessed files are stored here in this cache memory, just like the cache, what you have, the internet cache stored in your computer. In this SSD, here is the place where the cache memory resides. Next, you have the controller. So the controller is in charge of communicating with the host device, that is with your computer, as well as managing the flash file system directory. If you go to your Windows Explorer or File Manager, all those things are managed by this controller. When your operating system requests for files or directories or movies or picture files, anything and everything, this controller is the one that will provide the data, that will provide the information. This NAND flash memory is just like your plotter in the SATA hard drive. So this is the place you can see there are so many NAND chips are available. In these chips, the files, your operating system, your picture files, movie files, PDF, PPT, any of these kind of files are stored in NAND flash memory. Next, we have the fastest storage device, which is available, called NVMe. This is the advanced version of SSD. The SSD, what we had seen just now, this device will work at least 3 to 4 times of the speed of the traditional SATA hard drive, whereas this NVMe type storage device works at least 50 times faster than this SSD storage device. There are 2 types of this NVMe SSD storage device available. One is a normal NVMe SSD, and another one is called M.2. Okay, there are 2 different versions. Both function at the same speed. There is no difference. Here you can see the major difference is the connection type. Okay. Except this connection type, there is no other difference when it comes to speed wise. It will be functioning the same way, how it works. So what are all the major things when we have 4 pictures or 4 different types of devices? How different it is from each other when it comes to performance? You can see the first picture, that is 7,200 RPM, which is written over here. Okay, so this is the speed of this SATA hard drive. Got it? So for 1 second, it can read and write the data 200 Mbps per second. For 1 second, it can read and write at this speed. Whereas when it comes to this SSD hard drive, the same one what we have it here, this can work at the speed of 600 Mbps per second. That means this is much faster than the previous generation hard drives. The last one, the fastest one of them all is the NVMe, which is over here. This particular storage device works up to 2600 Mbps. Some of the latest one available in Samsung make, which can work 3600 or 4000 Mbps per second. That means 4 GB per second, the read write. So suppose you have this type of storage installed in your laptop or desktop computer, your Windows operating system can start within 2 to 3 seconds. The moment you power on the button, with a blink of your eye, you can see the operating system, that is login screen already there. It works so fast. If you are downloading a movie file, maybe a 2 GB file from your laptop or desktop computer that has got NVMe storage to external storage, maybe like a USB or a pen drive, that data transmission gets over within 2 to 3 seconds. The same time here, it may take about 3 to 4 minutes. So your total computer speed is dependent on the storage device as well, what type of storage device we are using. So in what way these devices that we are discussing now related to AWS? Correct? So that's the question, right? So it is these type of storage devices that will be used in our EC2 instance. So where do we see that? Let me take you back to my AWS Management Console. Let me try to create a EC2 instance. I'm launching an EC2 instance. So here I will skip all these steps. Straight away, I'll go to the storage device. This is the traditional storage device. This is a Linux-based operating system. 8 GB hard disk storage is picked. And what type of hard disk, whether you want general purpose SSD, general purpose SSD GP2. GP stands for general purpose version 2. Whether you want a normal SSD, you want cold HDD. This is the SATA hard drive, the slowest hard disk which we had seen in our presentation, and throughput HDD in that, which is working little bit faster. And very, very oldest technology, there is one more technology that was not shown in the picture, was magnetic tape based. This looks like exactly our old audio cassettes. Okay, that is also another type of storage device. So while you are creating your virtual machine, you can select any of this type of storage device. So based on the storage device that you have selected, your charges will be varied. Suppose you select normal this SATA hard drive, the first in the picture, your EC2 instance virtual machine prices will be significantly low, because this hard disk works at a very, very slow pace compared to SSD. Same time, it has got an advantage of huge storage capacity. This storage SATA hard disk maximum storage size which is available in today's market is 20 GB. 20 terabytes. 20 TB is available. Same time with SSD hard drive, it is hardly available about 4 terabytes of storage. Price wise, it is much, much costlier. So depending upon your requirement, you can select the storage type in your virtual machine. So what are these storage servers? It is these storage servers where these hard disks are stored. A storage server is also known as a file server or NAS, that is network attached storage. So it is a type of server used to store, retrieve, manage the data and applications. Let us have a look at the traditional storage servers, how exactly it looks like. Let's okay. This particular device, what you see, the picture one, it is a storage rack that has got many number of hard disks that are mounted on it. In this pictorial presentation, you can see there is one hard disk that has been popped out. This is a SATA hard drive, the one what we had seen in our previous slide, this one. Okay, so this hard disk has been installed in this storage rack. If you count from left to right, there are 15 hard disks that are placed one next to each other. You can see number 1, 2, 3, 4, like that, 15 into 6 rows. That is 60 hard disks or 90 hard disks are placed in this one storage rack. That means all these hard disks put together is one single drive letter, like drive D or drive E. Okay, so total it comes to about 1,800 terabyte, assuming that each hard disk is 20 terabyte of size. In one rack, you have 1,800 terabyte of storage. Okay, this is how the hard disks are placed one next to each other. In the second picture, it represents the rack, the storage rack. And in the third picture, you can see the racks are placed one above the another. This entire rack you can see here. This is one rack. This is rack number 2. This is rack number 3, number 4. Each of them has got 90 hard disks of 20 terabyte of size. Okay, this entire thing is one unit, one storage server. Okay, you can think about
one question.
Yes, please.
So in one rack, how many hard disks are there? 90?
See, if it is a SATA hard disk, it can be 90. There are different rack sizes are also available. In this pictorial presentation, 90 is what's shown. It could be even 120 or more. Same time, if you go for SSD hard disk, which can occupy much more in numbers, correct? So depending upon what type of storage we are using. Suppose we go for SSD, NAND, NAND, what we had seen here, this one, the fourth picture, it can have thousands of pieces in one single rack. Correct?
Yeah, got it.
So depending upon what type of storage device that we use. Let me erase this, whatever that has been marked. Okay, so this is one storage server. Likewise, you can see so many storage servers kept one next to each other. This is number 1. This is number 2, number 3, number 4, number 5, number 6. Similarly, backend also we have, correct? All of them is one single storage. It can be mapped as maybe this entire thing, we can map it as drive D in our computer. This entire thing, we can map it as drive letter E, which has got so many petabyte. 1 petabyte is 1,000 terabytes. Okay, this hard disk, what we are talking is only 20 terabyte. So 20 into 90 hard disk, what we have, which comes to 1,800 terabyte. That means 1.2 petabyte. Okay, so this storage will have so many petabyte of storage. Do we really need so many such a huge, massive storage space? Yes, of course. You take the example of Facebook. How many millions or trillions of users they are keep posting, uploading their pictures, videos, correct? Similarly, you take Twitter, Instagram. People, users, they are keep uploading their files. They are keep uploading their pictures. You take the example of Google Drive, correct? So these kind of storage, massive storage is required. This is not a traditional server. This is only a storage server. This will have a very, very minimal RAM capacity and the CPU. There will be separate servers itself like this, the virtual machines, what we create. These virtual machines will have connection to these storage servers. That means while creating a virtual machine, if you have opted 30 GB of storage for Windows Server or 8 GB of storage for your Linux system, a small portion of this is borrowed to your virtual machine and it has been connected. Got it? So this is how a storage server works. This is how our virtual machines get connected. Now, the upcoming slides will be learning in detail, in depth about the storages. What are all the different types of storages offered by AWS? All right. So AWS Cloud Storage Services, AWS provides a variety of cloud storage services, which are further classified into 3 types: a block storage, a file storage, and an object storage. Okay. So a block storage is a technology that is used to store data files on storage area networks. In short, it is called SANs, or it could be a cloud-based storage environment. Whatever the racks that we had seen in the previous slide, that is what the cloud-based storage environment. So it takes any kind of data, like a file or a database or a movie or a picture file, audio file, MP3, MP4, anything and everything, and that gets divided into blocks of equal size. That each block could be 512 KB or 1024 KB, 2048 KB. Okay, each block will have a small portion of that file. The continuation of that file falls into different blocks. So these are the different ways and means in the backend, the storage devices, the hard disk that stores the data. So the first type is a block storage. We have one type of the example in AWS environment for block storage is EBS, Elastic Block Storage. The traditional 30 GB or 8 GB hard disk, what we connect for our EC2 instances, they are block level storage. So the next one is file level storage. So a file level storage is a method of storing data in the cloud that provides servers and applications access the data through shared file system. Today, we will perform the lab exercise on each of the topic so that you will be able to understand in detail how these storages works. So under traditional file storage, we have 2 types of file storage. One is network file storage and another one is EFS, Elastic File Storage. So Elastic File Storage is used only in Linux or Unix based operating systems. However, network file storage can be used in both Linux as well as Windows based operating system. Why EFS is stored only in Linux? Because the file formatting structure how Linux uses, Windows cannot understand. That's the reason EFS can be used only in Linux or Unix-based operating systems. However, NFS can be used vice versa in any of the operating systems. So the last but not least is object storage. It is a computer data storage architecture designed to handle large amounts of unstructured data. It could be like NoSQL or SQL database. So this kind of large amount of data that needs to be stored in the cloud and that need to be accessed. It could be even our Amazon Prime or Netflix videos. You take the example of Facebook. You take the example of YouTube videos, what we cache, what we see, and even the Google Drive. All of them falls under this object storage category. So in the upcoming lab exercise, we are going to replicate YouTube, how exactly YouTube works. We will create our own YouTube server. Similarly, we will create our own Google Drive. We will upload some files. We will share that link, just like the Google Drive link. We will share it among the participants. They can view online or even they can download the data. Okay, so these are all the different types of storage devices, storage services that are available in AWS Cloud. Let's move on further. exploring what are these EBS, NFS, EFS, S3, these services in detail. Let's try to understand.